Behind every great technology lies a mastermind, an engineer who can envision, design, and bring to life complex systems that shape the world. But becoming that mastermind requires more than just technical expertise. It demands a deep understanding of system design principles and the ability to communicate your vision effectively. By the end of this video, you'll learn the secrets to cracking one of the toughest interviews in the tech industry, the system design interview. So grab a cup of coffee, sit back, let's take you through the journey to becoming a system design mastermind.
Welcome to the design system interview. After the first few questions, you may want to quit this interview, but do not quit the interview. My first question for you today, you are to design a chat application that can handle 1 million concurrent users. How would you handle scaling and what technologies would you use?
Vertical scaling, or scaling up, involves upgrading your existing server by adding more RAM or a faster CPU. While it's a quick fix for handling increased user loads, it's not a sustainable solution for long-term growth.
Is this the best approach to scaling?
Vertical scaling has physical limits, can become expensive, and creates single points of failure, making your system more vulnerable to downtime.
Are there any other approaches to scaling besides vertical scaling?
A more effective strategy is horizontal scaling, where multiple replicas of the server are added to distribute the workload. Each server handles a portion of the requests, making it a more robust solution than vertical scaling. This approach offers two significant advantages: unlimited growth potential. Simply add more servers as needed. Enhanced reliability. If one server fails, others can seamlessly take over, eliminating single point of failure risks.
Okay, well explained. Imagine you're building a URL shortening service. How would you design the system to handle a high volume of requests and ensure reliable redirection?
Let's introduce a load balancer. It acts as a traffic cop, directing incoming user requests across multiple servers to prevent overload and bottlenecks. By distributing traffic efficiently, load balancing ensures that no single server is overwhelmed, maintaining optimal performance and reliability.
So, how is traffic distributed across the system?
Load balancers utilize a range of algorithms to intelligently distribute traffic. Least connection directs traffic to the server with the fewest active connections. Resource-based selects servers based on their available resources, ensuring optimal utilization. IP hash assigns traffic to servers using a hash of the source and destination IP addresses. Round robin sequentially distributes traffic across a list of servers. Custom scripts allows for tailored algorithms to meet specific needs, providing flexibility and control. Several technologies are used to achieve load balancing. Software solutions like Nginx or cloud services, such as AWS Elastic Load Balancing, can be used to manage traffic distribution.
Okay, let's carry on to the next question. You are to design an e-commerce website. Explain the role of caching. What caching technologies would you use, and how would you handle cache invalidation?
Caching is a technique that alleviates database server bottlenecks by temporarily storing frequently accessed data in a faster, more accessible location, such as a computer's RAM. By doing so, caching accelerates response times for future requests, while significantly reducing the load on the database. To implement caching, choose from a variety of specialized software solutions, including Redis, Nginx, Memcached, Cassandra. We select technology based on system requirements. To maintain consistency between the cache and database, employ cache invalidation strategies. Two common approaches are write-through cache. Update the cache and database simultaneously, ensuring data consistency. Write-back cache. Update the cache immediately and synchronize with the database at a later time, optimizing performance.
Where is the cache?
Caches can be strategically placed at various levels within your application architecture. Client side, stored in the browser's cache. Server side, implemented using software like Redis or Memcached. Database, utilizing query caching in databases like MySQL.
How would you leverage a content delivery network, CDN, to further optimize the performance of your e-commerce website?
Another caching layer is provided by CDNs, which are networks of servers strategically located across multiple geographic regions. These servers store and serve cached copies of web content, such as images, videos, other static assets. By storing content in multiple locations, CDNs reduce latency and improve page load times for users worldwide.
How would you configure a CDN?
CDNs can be configured in two primary ways. Pull-based. The CDN retrieves data from the origin server upon the first user request and caches it. Push-based. The origin server proactively pushes data to the CDN for caching. Popular CDN providers. Some well-known CDN providers include Cloudflare, Google Cloud CDN, Amazon CloudFront, and Microsoft Azure CDN.
Great job so far. You've made it to the final question of the interview. How would you establish reliable server-client communication for our e-commerce platform? What factors would you put into consideration?
API design. Here are key considerations when designing the API. Type of API. When designing an API, first decide on the type: RESTful, GraphQL, or gRPC, communication protocol, HTTP, WebSockets, etc. Data transport mechanism, JSON, XML, or protocol buffers. Security. Consider implementing measures against dictionary attacks, XSS, CSRF, HPP attacks, and use rate limiting. Querying and sorting. How will the data be retrieved and sorted? Pagination. You don't want to get all data in one request, you need to paginate. Performance. Optimize the initial loading time of your app. Error handling. Make sure errors are consistent and informative. Congratulations! You made it to the end of our system design interview guide. With the concepts and strategies we covered, you're now well equipped to tackle even the toughest system design challenges. You should be incredibly proud of yourself for putting in the effort to improve your skills. Go crush that interview and land your dream job. You got this. If you have any suggestions for future topics or would like us to explore specific complexities, please share your thoughts in the comments below. Your feedback is invaluable. We'll see you in the next one.